Take this grammar. First, because the one grammar which we were discussing, the arithmetic one, you already have the DFA. You can take that as a homework for constructing the passing table. You'll get an idea. If I start constructing the passing table, it will be huge because we have to cover up more today. So I will take a smaller grammar than that, which will give me lesser number of states. So the passing table construction, writing, the shift reduce, everything remains the same. Okay, so if you do it for arithmetic expression, it will be more, you will get a hand on that. But you will get a lot of confusions if I start with that grammar. So let us learn a simple grammar first, and then we can go with the complex one. Anyways, you know how to write the DFA for that. So how do you augment this? What is the resultant grammar?
S dash derives S.
Then S gives ASB, S gives C. This is the augmented grammar. Find the first in the follow set for this particular grammar. First of S dash is first of S. What is first of S? What is first of S?
A comma C.
A comma C. Okay, first of S is A comma C. What is follow of S dash? What is follow of S dash? S dash, do you see anywhere here?
Dollar.
So it is only the dollar because it's the starting symbol. What is follow of S? Here, if you take follow of S is nothing. So follow of S dash will be there in follow of S union. Follow of S here, if you take it is B. So what it is dollar and B. Okay. Now construct the LR of 0 item set and the automata. So how do you start with the construction? You have to apply closure on the starting item. What is the starting item here? What is the starting item? I hope you remember.
S dash derives dot S.
Yes. So S dash derives dot S. Apply the closure on this. After dot, I have a non-terminal. So S's productions are already not there in the set. So I'll have to put S's productions as well with a dot. So ASB, S gives dot C. So this is state number 0. So after dot here I have A, after dot here I have C. It's a terminal. Okay, so no further items will be there in the starting state. This is the closure. Right, next I have to give the transition. For S I have to use the goto. What do? You have to, whenever you give a transition, you move the dot to the right of whatever after the dot you have, you move the dot to the right of one character next in the item. So you get S dot. So nowhere else you have after dot S. So it is a single item. So after dot you don't have anything. So this is the only item in the state. So state number 1. Then this is over. This item you take, give the transition quickly. S gives. When you move the dot, you have A dot. You move the dot to one character right side. So you get A dot SB. After dot, what you have? You have S. So you have to write S is production, right? ASB, S gives dot C. Okay. After dot, you have terminals. So no further items will be there in the state. State number 2. So next you have C. Transition on C. S gives C dot. Is it clear? Take state number 1. You don't have any other items. Here I have to give a transition on S, right? Because after dot I have S. No other items are having after dot S. So what do? S gives, move the dot and apply the closure. After dot I have B. So no further items will be added to the state. This is state number 4. If I apply the goto on this item, what will I get? What is the state?
Same state.
Same state. So it's a self loop on A. On state is state number 3. Okay. Now next, here if I take one transition is left, that is on B. So you move the dot and apply the closure. B dot. So state number 5. No further items. All the items are covered in the states. You get 0 to 5. Total 6 states in this SLR of 0 automata. Okay.
Excuse me, ma'am.
Yes.
Ma'am, in the production for A, the second one, you did not move the dot. What was the reason for it?
Here, this one.
Ma'am, S is deriving dot ASB. You did not move the dot as like the A dot SB. What was the reason for it?
In which state? State number 2 or state number 0?
2.
2. I've given no. If you move the dot, you will get the first item of the state, right? So all the items will be similar. Even if you give a transition on A, what will be? If you move the dot, you get A dot SB. So
Yes.
S production, you have to write ASB.
Okay.
Isn't it similar to state number 2?
Yes, ma'am.
So it is a self loop. Got it?
Yes, ma'am.
So now,
why have we written a separate transition like S gives C? We can write it as A, B, or C, right?
where? No, I didn't want to miss out any production, so I have written like this. If you are very comfortable, you can write as gives dot ASB or dot C.
Yes.
No problem. But going forward, now when you write CLR, the method of construction of DFA remains the same. You may have to write a look ahead in front of this. That time it will be a problem if you write a or for the same non-terminal. It is better to have that habit of splitting and writing. It will be easy for you to not to miss out any productions. Okay. So now the construction of the passing table. Now, okay, the passing table will have shift, reduce, actions. You will, as you remember, LR algorithm I have discussed in the last class. It has two parts. One is action, and the other one is go to. Action will have all the terminals of the given grammar with the dollar, and go to will have all the transitions on the non-terminals of the grammar before augmentation. Whatever the non-terminals are there, we have to list all of them. So here the stack will maintain the states, right? So here we have two parts of the table. The first one is the action, and you have the go to. Okay, action will list out all the terminals. You have A, B, C with the dollar, as same as the your top-down parser, okay, predictive parser. Instead of writing the non-terminals on the first column, what we do is we write the states, because the stack will maintain the set of states, right? So we have states here, and the go-to will have what is the non-terminal in the given grammar. Before augmentation, it is only S. Okay. So list on the states here: 0, 1, 2, 3, 4, and 5. Okay, we have 0 to 5 states. You have to do this table for the arithmetic expression. Okay. Now you have action, go to. Go to will have all the non-terminals. Here only one non-terminal we have. If you have more than one, like in arithmetic expression, you will get ETF. E dash will not come because that is introduced by us for the augmentation. Okay, so the go to will never have S dash, because in the production body you will never have S dash because we have introduced it. So you will get only go to transitions on the non-terminals whichever were there before the augmentation, right? So these are the terminals in the given grammar with the dollar. Now we have to write when to shift, when to reduce. Now from take 0, state number 0. Okay, what are the transitions we have? We are in state number 0. What are the terminal transitions we have?
A and C.
A and C. So from 0 on A, we are going to state number 2. So that is shift 2. Let me write it right. It is shift 2. Shift to state number 2 from 0 whenever you see the input symbol A. Okay. Then you have terminal transition on C from 0. 0 on C, it is shift to state number 3. right? This is state number 3. Now you have a non-terminal transition from 0 on S, it is 1. So you will write only 1, no shift, because the stack won't have the non-terminals on top of the stack. We don't shift the non-terminals, we shift only the states and the input symbols. Okay, so go to, we will write only the number. For terminals, we will write the shift action. There is no shift action for the go to non-terminals. Okay, it is just moving from one state to the other state. Next, state number 1, we don't have any transition from state number 1. Then state number 2, we have transition on S. State number 2, transition on S. What is the state number? It is state number 4. On S, 2, on S it is 4. Then on A, it is same state, right? Shifted to 2.
On C, it is 3.
Yes, very good. Okay. Now check state number 3. You don't have any transitions. State number.
In the diagram, should be corrected to C, right?
Yeah. It is. It's written 3. It should be on C. Yes. State number 4. You have B transition to 5. B is the terminal, so we will write a shift. State number 4 on B, it is S5. Any other transitions we left with? State number 5, no transitions. Okay. Shift is clear. On terminals, you have to write S for shift, 2 for what is the state. For go to only non-terminals, you will be writing the transition, the state number. Now, reduce action is little different from shift. It is not that, you for writing the reduction action in the passing table. Okay, you have to number the grammars first. This is 0, 1, 2. Number the productions in the grammar from 0. Then you take the last one. Take the last production. You have to see in which state you see this production body fully. That means you have to have an item like S gives C dot. That is the meaning that the production body is seen fully. The parser position is after, at the rightmost end. Okay, what is the state number wherein we see?
3.
3. Okay, so state number 3. So we have marked the state number.
Now, could you repeat the last point? Like we take the last production and
last production you take, you have to search in the LR0 automata in which state we see this item, the production body fully. Fully means the dot should be on the rightmost end of the production body. State number 0, it is there on the leftmost side. State number 2, you have it on the leftmost side. State number 3, you have it on the rightmost end. Okay.
yes.
You mark the state, and then under which terminal we have to write the reduction. For that we use the follow set. Okay, follow of head of the production terminals we have to take. So these two are the terminal symbols under which we will write the reduction. Okay, follow of head of the production we have to take to mark the input symbols. It is $ and B. Okay, state number 3, $ and B. So now we have to write the reduction. Reduce. What is the number of that? It is 2, right? That's why we number it. So reduce 2. So whenever you are reducing, you have to use this production for reduction. Okay, that means the C should be there on top of the stack and you're replacing C with S. That is the meaning. Okay, and write reduction 2 under $ as well because you have it in the follow set. Okay, reduction 2. Now, likewise, you tell me for 1, where do you see, in which state you see ASB fully?
State number 5.
State number 5, because you have the dot on the rightmost end of the production body, right? So mark state number 5. Okay, what is the head? Head is S. So follow set of S we have to take for the terminal symbols. What is follow of S? It is $ and B. So $ and B, you have to write the reduction. What is the number? It is 1. So reduction 1. Okay. Now you tell me for 0, which is the state. Where do you see S dash is S dot? First state. Yeah. So what is the head? Head is S dash. What is follow of S dash? It is $. So under $, you will have to write, instead of R0, we always write except. That means it is the halting state. That is where whenever you are reducing S to S dash, the parser should stop and say accept it. Okay. For writing the reductions, what you do, first thing is number the productions in the given grammar. Okay, I mean to say in the augmented grammar. What do you do next? Take the last production. You can write it in your own terms, however you understood. Last production and check and search in the
automata where the transition is full, that is the dot is on the RHS.
Dot is on the rightmost side. Okay, search
Extreme
the
right
automata. Extreme right. So mark that. You can make a note of this. Mark that state in the given passing table. Then take the follow set of the head of the production. Under that, you have to write the reduction with the production number. Okay, apply the same thing for arithmetic expression. You have already the DFA with you, and you have to construct the passing table. If you have any doubts, you can ask me. Okay, that is your homework. You have to do that. Now we'll see how to parse a given string using the parsing table. The DFA is done. We have constructed the passing table. Now we have to see how to parse a given string.
Ma'am, could you repeat the last point of that reduction thing? Like once we get the state in the table, then we mark our reduction in the follow set columns, right?
Follow set terminus for that head, whatever the
Yes.
production we have taken.
And the like R2, R1, that
R2 depends on, this number depends on how do you mark the productions, number the productions. You would have done it in the first step, right?
yes, ma'am. Like the R is for reduction and 2 is for the number of that production.
Yes.
Yes.
Yeah. Okay.
Yes, ma'am.
Now this is clear. Now we'll see how to parse a given string using this parsing table, like how we did for top-down parsing or shift-reduce parser. In the same method, we will try to parse the given string based on this parsing table. Okay. So let these things be there. What are the columns in the shift-reduce parser? You have input, stack, and action. I told you in the general parser also we have the same columns. Only thing is there we don't know the conflicts were there, when to shift, when to reduce. Okay, to avoid that conflict, we construct these states, and stack is made to maintain the state numbers, and it uses the parsing table to do to select whether to shift or to reduce these actions. Oh, I deleted. Okay, it's there here. I just number here only so that it's easy for us. Okay, input, stack, and action. Tell me one string which can be derivable from this. AA, CBB. Is it correct?
Yes.
Okay, you get AACBB dollar. Stack, we are writing on the right side, right? So dollar, initially we'll be pushing the starting state number. Okay, that is 0. Action, we have to see now what to do. Okay, initially we'll move like how we were moving the starting symbol of the grammar and top-down parsing. We move the state. Okay, state number 0. That is the initial state, because from there we have to do the actions. Now 0 on A. Refer the passing table. It is 0 on A. It is shift action, right? So shift S2. We are using S2. Now what we do, how we shift is, now I'm left with A, C, B, B, because this is shifted on top of the stack. So 0, A, 2. Okay, so 0 on A, shifted 2 on top of the stack. So always remember, on top of the stack we should have a state number only. Nowhere you will get a terminal or non-terminal. It will be there inside. Maybe it will be there inside, but on top of the stack you need to have a state number only. Okay, now you see 2, the input pointer is pointing to A. 2 on A, what it is?
Again 2 now.
Again shift. Okay, shift S2. So the pointer has moved to the next character, right? So I get C, B, B, dollar, and I get 0, A, 2. I shifted A, and state number is 2. Okay, this A is shifted on top of the stack with the state number 2 because it is 2 on A, it is S2. Now you see 2 on C. 2 on C. What is the action which I have to take? Shift to S3. B is left in the input. 0A to A to C is moved on top of the stack with the state number. Okay. 3 on B. 3 on B. What it is? It is R2. Right? R2 is what? R2 is a reduction. Now, what is the reduction which I have to apply? I have to apply reduction SQS.S, right? So this production, that means C I have to find on top of the stack and I have to replace with S on top of the stack. Is it clear? So it is reduce R2. Okay. Now you have to find what is there on top of the stack. Where do you have C on top of the stack? So till then you mark it. Okay. So till C. C I have to find on top of the stack because I am applying this reduction SQS.S. Okay, C3 I have to replace it with S. So now I'm remaining with BB dollar 0A to A2. I can do shift or reduce actions. Now I can look up the table for shift or reduce actions. Got it? So 4. Now top of the stack is 4, state number 4. What is the input pointer? Pointer pointing to B. 4 on B. 4 on B, it is S5. So I got again shift S5. Okay. Now, after shift, 1B is left in the input pointer, pointing to 1B, the last B. Dollar I have 0A, 2A, 2S4. B I have shifted, and the shift number is 5, right? So 5 on B is what? It is?
Reduce R1.
R1, yes. So reduce R1. Now tell me what I have to find on top of the stack. R1 is nothing but SQS. Huh. So how do you find? You have to find the
In top of the stack is A, we have to mark.
So I have to take ASB. Do you see ASB on top of the stack? Ignore the state numbers. You have ASB, right? So this has to be reduced to S because this is a production which we are applying, right? So what do I write? 0A2 as it is. ASB is reduced to S. Now what should I do? I have on top of the stack non-terminal. What shall I do?
Go to 4. S4.
So I have to refer the go to. So 2S because I have 2S. 2S, I have the reference of go to. So state number 4. Okay. Now I can move further. 4 on B. What is 4 on B? It is shift.
5.
Yes. Shift is 5. Okay. So I have to shift whatever is there on the input pointer pointing to. So I remain with dollar 0A to S4 B, and this is state number 5. Okay. Now you see 5 on dollar, what it is? It is again
R1.
reduce R1. Okay. Reduce R1. Now again you have to find what is R1. 1 is nothing but SQS ASB. ASB you find on top of the stack, you have ASB. Okay, this has to be replaced with S, isn't it? So dollar, you have dollar 0. It is replaced with S. 0 on S. What is 0 on S? It is
1.
1. Okay, I got the state number 1. So 1 on dollar is what? It is?
Accept.
Accept.
Yes. So it is accept. So this is where it halts. So this is successful when the input is fully seen, fully passed. You don't have anything on the input. Okay. And on top of the stack, you get 0S1 and the lookup. Here, the main concentration is on the lookup. The lookup, if it says accept, then it is accepted. Usually, you will get this 0 with the non-terminal of the starting symbol of the grammar and 1. if you further parse a few more strings, no, you always get 0s1 on top of the stack, because we would have introduced s dash, right? So you will always get dollar in the zeroth state for, in the first state for this one, and except R0 for this production. So when you're writing reduction, search on top of the stack that particular production body, replace it with the head of that production. Once you replace it, you will get a non-terminal. Refer the goto for getting a state on top of the stack. From that state, again, check the input symbol reference for making shift or reduce actions. I'll give you a small problem so that you can complete in time. E gives E plus N, or N is the grammar. Augmentation you have to do, find the first and the follow set, construct the LR0 automata and the passing table. See, we construct LR of 0 automata, right? And LR1 passing table, because we refer to look ahead symbols. So that's why it is one passing table. In LR of 0 passing table, what they do is they don't see the look ahead symbols. Okay, for writing the reduction, they'll just fill up the entire row for all the terminals, the reductions. Okay, that is LR0 parsing table. We don't use that because it doesn't give a proper action. So we always construct a SLR1 passing table or LR1 passing table, which uses the look ahead symbols for writing the reductions under the terminals. Okay, we select the look ahead symbols and write the reductions. In LR0 passing table, we just write R2 for all the terminals on that state, which is not correct. Okay, that is the difference. So always we construct LR1 passing table. Quickly, I'll just augment and write the DFA here only. You can separate it into two different steps. So E dash gives dot E. I have to apply the closure on this. You get E gives dot N. This is state number 0. So from here you get E transition. You get both the productions in this because you have after dot E. So E dash E dot. E gives E dot plus N. Okay, after plus you have terminal, and here you don't have anything, so you don't get any other items. So you get a transition on N, E gives N dot. It's a very simple grammar. So 2. Okay, and here on plus you get E gives E plus dot N. After dot you have a terminal, so no further transitions. On N you get E gives E plus N dot. This is for practice. Because you may get confused with the reduction. If you practice, this can be done very fast, because you will get this question, you have to solve it in 15 minutes, I guess 15 to 20 minutes. More than that, you won't have time, right? So till the passing, we'll ask you. And every time, don't expect that this tiny grammar will be given. So action you have plus N and dollar, right? Go to, you will have only E. 0, 1, 2, 3, 4, right? Tell me shift and reduce actions. Where did you get? 0?
N is shift 2.
Then?
1 plus S3.
2 on N, S4.
2 on...
3 on N.
3 on N, S4. Now coming to the reduce part.
Go to.
Go to 0 on E is 1.
Okay.
Now the reduce part is on state 2, plus and dollar will be R2.
Plus and dollar will be R2. Okay.
Similarly on state 4, plus and dollar will be R1.
Then?
And on state 1, dollar will be XN.
Yes, that's right. Good. Now CLR will be easy for me. Only thing is, items you have to add the lookup symbols in the state only. Only that difference is there. We can another 2 classes this week. I will complete bottom of parser. Error recovery we have to see. Okay, and please pass this string, right? And for arithmetic expression, you can take ID star ID plus ID as a string for parsing. Because construction of parsing table, we didn't do that. you have to construct the parsing table and parse the string for the arithmetic expression. 0 to 11 states we have, right? For that, if you can do that properly, any grammar you'll be able to do, because it is having a lot of states.